Here's a tutorial on how you can use Excel to help you plot data and find a line of best fit. I'm taking this as an example from your textbook, page 188, number 7. And this is a chart of how many individual income tax returns in millions were filed in the United States in the years between 2000 and 2009. So first of all, you want to put all of your data into the Excel spreadsheet. So in my A column, I have all of my X coordinates. So I'm going all the way from 2000 to 2009. So instead of the year 2000, I write 0. 2001 becomes 1, and 2009 becomes 9. In the B column, I'm writing my Y coordinates. So this point here, the first point, represents that in 2000, there was 125 million tax returns filed. In 2004, there were 130 million tax returns. In 2009, there was 139 million tax returns. So now I want to take this data and I want to graph it. So I'm going to highlight all the data that I want to graph, and I'm going to choose Insert and Scatter Plot. I don't want to connect the dots, so I'm just going to choose a scatter with only markers. And there I see my graph, which kind of looks like a line, but not really. I'm going to try to put a line of best fit to the data. So I'm going to click on the data and then right-click and choose Add Trend Line. When I add trend line, I don't want to add an exponential or logarithmic or polynomial. All these are curves. I just want a linear line, and I want to display the equation on the chart. I also like to display the r-squared value on the chart. So I'll close that, and now I can move my line over here. So the equation of the line is y equals 1.4545x plus 125.05. So that tells me my slope and my y-intercept is in y equals mx plus b form. The r-squared value tells me how close I am to an actual line, how close my data points are to a line. If that number is very close to 1, then it's really close to a line. In this case, 0.95 is not so close to a line. You can see that this graph has kind of a curvy shape. So I'll also show you how to do this in a TI83 calculator. Let me grab out my TI. And if you have a calculator, you can also do the same thing. You should get about the same answer. So hopefully we will. So let's take a look at our data again here. So same thing. First I've got to put the data into the calculator. So I'm going to go to Stat menu, choose Edit. I want my list 1 to be all the numbers from 1 to 9. For all the years from 2000 to 2009. I'm going to go across to my L2, and I'm going to put in the data for the number of tax returns filed. Just hitting enter after every piece of data is inserted. Okay, and then I'm going to go to my graph, and I want to plot a plot of data points. So I'm going to turn my plot on. So I go up until I hit the plot so I can go around here. And I want to hit enter when I get to plot 1. And I'm also going to go yellow button y equals so that I can edit these plots. I want my plot to be on. I want the type to be scatter plot, just like before. I want my X list to be L1 and my Y list to be L2. So now when I graph that, I should see some points, but I don't. And that's because I'm not looking at a big enough window. So my X is going from 0 to 10, and so is my Y from 0 to 10. But I actually want it to go all the way up to 140. So I need my Y values to go at least up to 140 so that I can see them. I'm going to change my maximum Y to 150 so that I can see my Y values. There they are. Okay, in order to make the graph the same, I would just choose the same window. So on this graph, they go from 0 to 10. And they go from 124 to 140. And if I do that, then the graph should look the same on the calculator as it looks on Excel. There it is. So in order to find the line that fits that data, now I'm going to go to my Stat menu, and I'm going to choose Calculate. So go across one and choose number 4, which is Linear Regression. And I want it to calculate the linear regression. If I just hit enter, I think this will work. Yes. Okay, so 1.4545 is the slope, just like it is on Excel, and 125.05 is the y-intercept. If I actually wanted to graph it and check, I could go and hit type in the equation that I found, 1.4545. The nice thing about the calculator is it gives me a little bit more decimal places than Excel does. And then plus 125.05, and then I could take a look at the graph, and it plots that line just like Excel did. And it's the line of best fit. So that's how you can use your calculator or your Excel to solve the last problem in your homework assignment.